All right, so I'll show it up here on the desktop. So when you open up 7.5.1, you'll see what I have up on my screen here. I meant to change the resolution on the screen. Hold on. Let me stop this application sharing real quick. Yeah, that's better. There we go. So when you download and open activity, you want to be downloading the activity 7.5.1. It looks like this. So last week we went over the network layer, and the Ethernet layer. We talked about how Ethernet works. We talked about layer 2 primary functionality. And so we're going to try to complete the loop on some of those discussion items in these activities. So I want to take a look at this one, and I want to cover kind of what's going on. So let's I'm gonna teach you how to do this. I'm gonna have you kind of do it in an exercise. I'll kind of write up here on the board what I want you to look for, and then I'll show you how to do it. Okay, so as you can see here, we're going to go from PC1 to PC2, right? And we're going to send just simple ping packets across. Don't send any ping packets yet, because we want to make sure that certain things happen between this and switch. So don't send ping yet. But what we're going to do is you're going to send a ping packet, and what we're going to watch happen is the data link layer is going to change between each device, but the IP layer will stay the same. So that's basically what we're going to look for. That's what we're going to try to prove tonight. So you can understand this concept of routing. Now, so I'm going to with this notepad up here, I'm going to put in several points. So I'm going to call this point A. And I'm going to create another one called point B. Another one called point C. Point D. Point E. F. And I'll call this point G. Actually, I'll just go to F for now. We'll add some more in a few minutes. Okay, so we'll just go from A to F. Okay, that's good. All right, so and then So I'm going to write some questions up here. So I don't know if you can see that very well. Let me, I'll write it on the board. So I'm going to write some questions now that I want you to try to figure out. And then I'm going to show you how to do it, and then I'll let you work on it. So, first question. What is the logical or layer 3 addresses for PC1 and PC2? So I want you to figure out what the logical or layer 3 addresses are for PC1 and PC2. Hence, that's the IP address. Right? Okay, number 2. What is the physical or layer 2 addresses for PC1 and PC2? 10. That's the Ethernet MAC address. Okay. All right. Then I'm going to have you answer a series of questions. Number 3. What is the layer let's say this. For the first ICMP echo request frame. So for the first ICMP echo request frame, you're going to answer the following questions. What is the layer? What is the layer 2 protocol? And the destination physical and logical addresses at points A, B, C, D, E, and F. Yeah, okay. So you're going to find out what the IP and the MAC addresses are for these 2 PCs. Should be pretty painfully obvious just looking at the diagram of the IP addresses. Then you're going to tell me what I'm going to teach you how to send an ICMP packet, and you're going to tell me what the data link layer is and what the physical address is and what the logical address is when the packet hits here, 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 and here. So you'll see a little envelope go across. And as the envelope goes across, you're going to answer these questions. All right, you got it? So let me show you how to do it, give you an idea. So first off, you're going to go into simulation mode up here. See where it says real time? You're going to click on simulation mode. And it's already doing it. So you're going to click capture forward. Now, Click capture forward again. Notice we have a packet leaving PC1 and going to this router, right? Everybody see that? Click on this green envelope. Okay, this is not, and click on inbound PDU details, and you can see the Ethernet to frame and the ARC protocol data. Now, it did not send an ICMP, it sent an ARC. Now, what is special about the destination MAC? Look at the destination MAC address. What is special about that? The destination MAC is not all zeros. It's all ones, right? And F in hexadecimal is what? So if you open up your calculator and you go to programmer mode and you were to make a hex character F and convert it to binary, you'll notice the hex character for F is 1. So we have 4 ones for every F. So how many Fs do you see here? 12. 12 times 4 is 48. 48. So a MAC address is 48 bits long, or ones long. So this destination MAC address is all ones. That's a special address, and we have an idea of what it means. When I send an all Fs out on the network, what do you think it means? Well, it means a broadcast. Okay? So this is what is called a broadcast. Now, why did the machine send a broadcast out? Okay, so let's not get what's that? Okay, let's talk through this very slowly. I want you to understand it. Let's get it from the very get-go, okay? So let's go through this process. The computer is trying to send a ping packet to the machine over on the other side of the network, right? 192.168.5.2, right? It's trying to send a ping packet. Does it know how to get the ping packet to that machine? It does not. This computer does not know. So this computer does not know how to get to the 5 network. Who does it hope knows how to get there? The router. So this machine has programmed into it something called a default gateway, right? So who is probably this machine's default gateway? The router. So it is going to send and now you have an idea of why it might have sent the broadcast packet out. You make the connection yet. It doesn't know where it's going. So it's got the IP address of its default gateway. But what does it not have for its default gateway? So I want you to think about this on an electronic level, right? Let's get down to electricity. So let's say every machine in here needs to talk to each other, right? On an electrical level, right? With voltage. How does this guy know that that it's being talked to? So if you wanted to talk to this machine and send electrical voltage to this machine, how would this machine know that you're talking to it? Yeah, but if we're all talking on the same wiring, we're all talking different times, you're going to be seeing lots of voltage. So how does it know that that voltage is intended for you? But how does it know that that query is for me? How does it know one voltage over another voltage? Some kind of query that it's supposed to talk to, like a Well, good idea, no, but it's a good idea. So every network card has a jack in the back you plug the electrical cable into. There's nothing special about that. So this is all electricity. So I made an electrical connection by plugging the cable into the car. So it's not a port. What else could it be? How does this machine know that that voltage is destined for it? What's that?
From its physical address.
From its physical address. So here comes this voltage coming across, right? And it's coming through your network card. Your network card on your PC picks up this voltage. It immediately starts converting that voltage to ones or zeros, right? When it sees what is called a preamble, which looks like this, it's actually 8, did I get 8 yet? It sees 8 ones and zeros. It knows that something is starting. Start. Right? So it sees this pattern of ones and zeros, something starting. The very next thing that happens is, guess what? The physical address. Right? Or the MAC address. Media Access Control address. That's the very next thing that comes through. And this is going to be 48 bits of ones and zeros. So that's how your machine knows that he wants to talk to you. He's going to send out a frame, and right after the 8-bit preamble, this little part, right after the 8-bit preamble, what's going to follow? The physical MAC address. And your machine's going to see that 48-bit pattern, and it's going to go, aha, that 48-bit pattern is for me. And it's going to continue reading the packet, or the frame. What happens if that 48-bit is not for you? What is your machine going to do? It's going to ignore it. It's going to discard, throw it away, forget it. I don't care about this. Not for me out here. You understand? Why is it so imperative that that 48-bit be right away? It'll know it's for me, and I don't have to waste any more time, right? This is all about time. We're transmitting these things at the speed of light. When you transmit that frame over here, it's going roughly at the speed of light. When I'm doing things at the speed of light, I don't have time to jack around with reading the entire thing to figure out what my IP address is. I don't have to go all the way up to layer 2 to layer 3 to the IP address, pass it all the way up to your machine into the protocol and look at it and think about it. I don't have time for that. I need to know right now. Does this make sense? So on any network, Ethernet-wise, if this machine wants to talk to this machine, what does it have to put right after the preamble? The 48-bit MAC address. So why, then, maybe we can answer the question now. Why did this machine first send a broadcast out? It sent an ARP broadcast. What question do you think it is asking? It's telling it what machine it's the exact opposite of what you said. It's not telling us what machine it's talking to. It's asking what machine I need to talk to. So it knows the IP address of the router, because it knows it's default gateway, but what does it not have yet? The MAC address. So it sends a special frame out, and the special frame is all ones. So here comes the Ethernet frame to your machine. It sees the preamble. You start reading it. Now it sees a string of ones. And guess what that means? I got to look at that. It's a broadcast. A string of ones means it's destined for everybody. Meaning we're all going to receive it. And we're all going to see the string of ones. And we're all going to look at it. We're all going to spend time on it. Right? This is why we don't want a lot of these going out on our network. The more broadcasting, the more time you spend looking at it. Right? So here comes the broadcast. It's all once. We're going to look at it. You're going to process it. So you're going to process this, right, all the way up to this point. You're going to say, this is an ARP, and what is the destination IP it's looking for? Target IP. No, target IP. So you're going to say, well, I'm IP 192.168.1.5. I don't care about this because that's not my IP. Forget it, right? But what's the router going to do when it gets this? The router, who is target IP 1.1, is going to say, oh, you need to know my MAC because you think it's all zeros right now. You need to know my real MAC. So guess what it's going to do? Send the MAC back to the receiving machine. So let's watch that happen. So watch what happens. Capture forward. Here it comes back. Let's look at it as it crosses the switch before it gets back. Let's look at the inbound. So let's see if you're following me here. Destination MAC. Whose MAC do you think that is? PC1. You understand? Why would that be PC1's MAC? Yeah, the router is sending the ARP reply back to PC1. It's got the preamble followed by the 48-bit MAC address of PC1. So when PC1 sees this come across, it's going to go, aha, it's for me, right? Source MAC. Whose MAC do you think that is? That's the router's. That's where it came from. So your machine's going to look at this and go, ah, 806, what do you think that refers to? We talked about this last week. 806 is the Ethernet 2 type code. And what do you think the type code references? Remember, what was one of the reasons, what are the functions of the data link layer? The data link layer needs to do what? It needs to error check, it needs to address, it needs to arbitrate, but it also needs to I know you studied hard all week long, memorized your facts. I know you did. So what is the other thing it needs to do? No, that's transport layer. So we arbitrate, we address, we error check, and we encapsulate what? Identify. So what is this doing? It's identifying what is in the package. So what do you think 806 represents? ARP. Now why do we need to identify the package? Did I give you the Christmas tree analogy? So you and your brother or sister are sitting at the Christmas tree on Christmas Day. I don't know if you celebrate Christmas. Pretend you do. So you're down there at the tree, and there's a whole bunch of presents under the tree. And you're so excited. You want to open the presents, but all the presents don't have a name on them. So your sister grabs the first one, rips open the package, and it's the most favorite thing you've ever wanted to have, right? And she's like, I don't want this, right? And she discards it, right? So why do we need to identify what's inside the data? So we need to know who to send it to. So the machine knows to send this to ARP and not to IP, right? And not to, or something else, right? So it's the Christmas tree analogy. It works pretty good, right? So we send it to the right person. So we're going to send this up to ARP. ARP is going to get it, and what is it going to see? It is going to see what right here? It is going to see the source MAC. So now what does it have? It knows the MAC address that belongs to the router, the default gateway. So let's watch what happens next. So there goes the ARP. It hits PC1, and PC1 is now able to create an ICMP. I'm clicking on this one right here. I'm clicking on my outbound PDU, and guess what it can do now? It creates scroll down, it creates an ICMP echo request, right? So it's sending an ICMP echo request type 8, which basically means, hey, I'm going to ping you, send something back. I'm just testing here, send me something back. That's what this means. So my ICMP echo request. It's very simple. But the more important part is the IP header. What IP is my destination IP address? .5.2, right? That's my destination IP. You see that? Whose IP is that? No. That's PC2. Yeah. Now, the destination MAC, whose MAC is that? Is it PC2's? No. It's the router. Now, why am I putting the MAC address for the router as the destination, but the IP address of PC2? Why am I doing that? The router knows the way, right? The router knows the way to get there. PC1 doesn't know how to get there, right? So PC1 is going to send the IP packet to the router. It's going to encapsulate it in Ethernet with the destination address of the router. The router is going to get this little Christmas package, and it's going to strip away the wrapping paper, and it's going to look at the contents. And it's going to decide, oh, that's not for me. That's for somebody else. I'm going to go and repackage it and send it on its merry way until it finally gets there. You follow me? That's what's going to go down. You're going to watch that happen as you navigate each frame. So you're going to answer the first two questions to see how that's straight in your head. And now what you're going to do, at this point, you're going to click capture forward, and you're going to wait till it gets to the point that I told you to look at. Aha! And then you're going to click on it. And you're going to look at the inbound PDU details. And that is what you're going to write down. So what is the layer 2 protocol being used here? The layer 2 protocol being used here is Ethernet 2. No, you're far advanced. You've got too far advanced. So let's look to it. This way. Now you're okay. The first three is still the destination package. So we take a look at you get the coded I don't know code solid. You'll know this. You need to see the arc. That's okay. You have enough to go. You didn't see the arc only because your machine already has that. Okay, so here's what you're looking at. So this is how I'm going to answer for number A. So Ethernet fusion protocol. What is the destination physical address here? This is the destination physical address, right? What is the destination logical address? Right here. So I want you to answer those questions at each and every point. Okay? Shouldn't be too hard for you. First, answer question 1 and 2. Do you know how to answer question 1 and 2? Let me make sure you do. So on question 1, you're just going to open up PC1. go to desktop, go to command prompt, and type ipconfig/all. This will tell you the IP address and the MAC address. So do that on both PCs so you can get the IP and the MAC. All right, so go ahead and go through this process and see if you can answer the packet point at A, B, C, D, and E, and F. Yeah, so I think it's big tall. You have to put a space between the slash. Have you noticed the trend with the logical address yet? Should be easy to spot. Yep, never changes, right? The logical address does not change. It's an important principle to remember. No? What do you get the back of the no, the physical address, the Ethernet, that would layer 2 protocol type types. Where you I think it's pretty simple there. So I should write down the layer 2 protocol type, right, which is how you see what the destination MAC address is. And then I want you to write down what the destination entry is. Okay. So now we're going to continue. Next, then C. It's now point B, right? Click on it, and now we can use this. Let's go to that protocol. There you go. What's the address? And then what's the destination be? How about you go for? Okay. So we go. I've always said this. Capture board. And when this gets to A, it's just a click. And then match it to this. Look to that one, I'm going to go. What's the destination MAC? Here it is. And what's the destination B? That would repeat it. Now it's at point B, right? You click on it. Shoot down. Destination address. Destination address. The first protocol type. Address. Destination address. Okay. So then do it again when it's C, do it again when it's D, do it again when it's E, do it again when it's S. You got it? Look at your answers. Okay. Yeah. I think you're right. Oh, okay. Oh, cool.
stage this.
Okay. But the address is
That's why they don't use it. It's not used.
oh,
It just means next time, basically. Just you can't. You do.
But mine couldn't go there.
What?
Mine couldn't go there. When it,
The first one's going to fail.
when it got there, it started sending this thing.
Yeah, the first one's going to fail. And why is that?
Because it doesn't know.
Because the router does not know PC2's MAC yet.
Okay.
So the router's got to ARP for PC2's MAC.
Okay.
And then the next one it sends will work.
Because then it just started looping CD over and over and over.
Or you just got to keep going until they're done.
There's a lot of them.
Yeah, just keep doing you know. CDP is a noisy protocol. In fact, in the second class we take in the Cisco series, the first thing we learn how to do is how to turn CDP off. Because it vomits all over your network.
I'll just go with
I forgot the,
we could just look the filters and put it on.
yeah, you could just filter CDP out, yeah.
It won't stop doing it.
What?
It won't stop doing it.
Oh, is it still doing it
Yeah.
over and over and over and over and over again?
Yeah, it's just like start looping it for a long time.
Oh, that's because nothing's happening. So it gave up on your SCP packet. So what's happened is your SCP failed. So click reset simulation and you go over again. So what's happened is it failed, and now all you're seeing, the only thing that's happening activity-wise in this network is CDP. So that's what's going on. I forgot I was going to go get it. I need a help for this display today. I better go get it. It's your guys' fault. You guys were all dragging your feet on getting behind. Well, you finally had to. When it was too late, all down was down. That's impossible. Okay. Okay. All right. Yeah, well, you can, but it's, performance is the issue. All right, I gotta go. I know. Okay, that's not be there. All right, everybody down with that, I think? So, you should have seen some patterns. First pattern that you should see is that PC1 knew the IP address of PC2. And PC2's IP address, the destination IP stayed the same across all the frames, right? So as it went across every layer, it stayed the same. But what changes? As we connect to each device, the physical layer changes, and therefore the Ethernet, the layer 2 protocol changes based on the media type. So each of these routers change out or change the packaging, if you will, to match that network. And therefore the destination address may change or not even be required altogether because we're using a link that doesn't require a physical address. Okay? So that's what you should have seen. Did you see that? So the MAC address for here was just to get it to here. IP stayed the same. Right? Hopefully you saw that pattern. That's what this was designed to do. Is let you see that. Okay. Next exercise is to do something a little bit more complicated. And we're going to be preparing for an exercise we're going to be doing next class by doing a little bit tonight, and then also getting a little bit of hands-on experience with Wireshark tonight, and also a little bit about how this lab works, because the activity I'm going to do next week requires a lot of movement and stuff. So there's some cables in here. So let me kind of show you how this works. So every one of you have on the back of your desks here, there's a push button pad that doors it open. So in the back of here you have a PC. And right now, connected to the back of your PC is a blue cable. This blue cable goes to a box in the floor. The box in the floor has a lid. You're going to pop the lid off. Inside there are jacks, and the jacks are numbered. You are not going to remove the blue cable. You're just going to simply unplug the blue cable and then leave it dangling. Right?
On the back of the machine.
Yes, in the back of the machine. Don't unplug it from the floor. Leave it in the floor, because we need this classroom to work when we're done. All right? So you're going to run a cable that I'm going to provide you from another jack. There's 6 jacks. 1, 2, 3, 4, 5, 6. You're going to pick one of these jacks, and you're going to run that cable up to your machine. Okay? Now, your jack will be labeled with a letter and a number. The letter represents A, B, C, or D, referring to the patch panel that you see up there. These are called patch panels. So your jack that you plug into is running into one of these patch panels. And so as soon as it can be A followed by a number, it'll be A all the way to 48. A, 1 through 48, B, 1 through 48, C, 1 through 48, D, 1 through 48. So you're going to run a cable from the back of your machine into a jack. And when you come up here, you're going to find the corresponding number
So if you were B10, you would find B10, and you're going to run a cable. You're going to get another cable. You go from B10 to a hub. I'm going to give you, which is right here. And I'm going to go get the little rack screws and screw it into the rack. Just give me a minute. So I'm going to power this little guy up. I'm going to stick it in here, and you're going to go from here to there. And all of us are going to be programmed on. We're going to be on the same hub. Okay? Now, before you do that, you need to log off your machines as you and log on as network. You remember how to do the local logon thing? Okay, so when you get to the screen, you're going to hit Control-Alt-Delete, and you're going to type the name of your machine. So you click on how do I log on to another name and write your machine name down. Click on how do I log on to another domain, write your machine name down. And then you can type the name of your machine, /NETWK. NETWK. The password is brute force with the B and the F capital. That's how you get into here. I'll help you with that if you have problems with it. But I'm not going to help you until after getting arrested. No. When you click, how do I log on to another domain? It'll close it.
So what are we backslashing? The whole one is network, or is it in? The first question I asked them.
Yeah, I decided to use the machine hub. Well into the past, circa 1982. It's more than archaic. This is the hub my grandmother used. I provided all this equipment I donated from years ago here. Most of this equipment here is mine from years ago. Okay, don't plug it into hub port 1. Avoid the port 1 on this hub. Don't plug it into port 1. What?
Alright, I'll help you.
Okay, okay, who's having one long in? You all are. Okay, network NETWK, capital B, capital F, and group force. So take the capital F out. So NET, network. Oh. And then capital B, capital F, and group force. You get through it? That is not right. Yours is student 970-12. You got to get logged on before you can plug your computer.
Otherwise, you'll never log on again. You got to get logged on before we do the exercise. So once you're logged on to the network, you can start doing your cabling. No, it's not right. You want to exclude 970 exclude 970 We get to work? All right, let me know. Let me know. Well, I'm on this trip where I eat the exact same thing every day.
Sounds nice.
All weighed out perfectly.
Yeah.
I got sick and tired of trying to plan out what I'm going to eat all the time.
Yeah.
So I said, you know what, forget it. We're just going to do the same thing.
So we're going to use any of those blue ones?
Yeah, use the blue ones. Or the I think the orange ones will work too. Did you get logged on? So you make two tables, one for here and one for here. You get it over there? There you go. Now you can do your table. What's that? Yeah, you're doing it. No, you're not going to do that. You're going to do that one. You're just, it's under there. You're going to look. They require a bit of investigation.
Oh, all right.
Oh, and these tables do move.
Okay.
They're on wheels. Just follow the blue cable. Follow the white rabbit. Yep, sorry. Any port, just make sure you get the number down. Is it hard to get down there? Why don't you put that back down and then roll the table back? That way. Call me. That way you don't have to call. I don't want you to have to call around. There you go. That's perfect. Now you can. There you go. I want you guys to get used to doing this because I'm going to be doing it again next week with a little bit more complexity. So. What? You know what? I keep saying that. Why document when I have your pants in there? Oh, I brought a screwdriver. You need help prying the lid off. If you need to pry the lid off, I got a little screwdriver. Is your lid not come off? Good. Okay, so I got one going from anybody else need a tool to pry off the lid? I got one going from the machine to the floor. And you wrote down that you know the number and the B27. Then go over there and find B27 and plug it into the.
Oh, I get it.
Just not one. Anything else? Okay, and hopefully you get a light. Do you get a light? Yep. Then that means you did it right. So hope. Yeah, see, your number 2 should be lit, right? Yay. Number 6 lit. Yay. So your light should light up. You get a link? You got a light?
Yeah.
Did you get a light? Oh, I want to do it. Okay. Look at the HUD and look at the corresponding language. All right, you lit up.
Do you like that?
Everybody lit up? Everybody got lit? All right, sweet. Now, so on your desk is number to number, right? So we're all going to make ourselves an IP address. We're all going to give ourselves a layer 3 address in the 192.168.1 range. And guess what yours is going to be? 1 dot, the number on your desk. What's the number on your desk?
03.
Yeah, so you're going to put 3, not 0.
3.
So what are you? So you're going to be 1.6. So you're going to change your IP. So you know how to do that? If you don't, listen up. So go to the control panel. Find something that says network. I think it's Network and Sharing Center. So you're going to find where you should see local area connection. Well, you only want the one with no number after it. And then you should get something that looks like this. See it? And it should say IP4 connectivity internet, right?
No, no internet access.
Well, that's IP version 6 connectivity.
No internet access to video.
Oh, that's because you unplugged yourself from the network. Never mind. All right, so click on Properties. And these are your bindings. And look at all the things you have bound to your network card. No wonder things are so slow. All right, now click on the TCP/IP version 4 protocol. Don't check the box. Don't check the box. Click on the text, Internet Protocol version 4. Got it? And go to Properties. It was a little easier in Packet Tracer, wasn't it? You got it? I only go 1 speed fast. Okay, so starting all over. Starting all over. We're going to go to Start Control Panel. We're in Control Panel. Find Network and Sharing Center. Find Local Area Connection, without the number. Click Properties. All right, find TCP/IP version 4 and choose Properties. You should get this window. Remember how to do this. Remember what this looks like. I need it to look like this again before we go home.
What looks like?
This screen right here. So it's obtain IP address automatically and obtain DNS server automatically. It's using DHCP. I want it to look like this again at the end of the night. Otherwise, no working class tomorrow. And I get blamed for it. And then they threaten to take away my administrative access. We have a committee meeting to discuss what to do about Guy's class again.
So this has happened before then?
Worse. All right. We installed some hacking tools one night, and everybody got mad about that. I had a bunch of web servers running in here, and they all got infected with some virus, and they were running some porn sites on them. It wasn't good. I had a lot of explaining to do. So, all right. So you're going to click Use the following IP. And then here's where you're going to type in your IP that I gave you. And since I think I'm 1.25, right? And then your subnet mask will be a /24, and you know what that means now, right? You're a /24. You know what that means. We're speaking the same language, right? All right, I hope so. All right, so this is what you're going to set it to be. Now, don't put 25, put your IP, which is your desk. And then click OK, click OK, click OK, click OK. So you can click OK, click OK, click Close. All right, everybody with me? Okay, now, we are going to run Wireshark. Actually, I should have done this too. I should have connected myself up too. Maybe I will do that. No, if I do that, I lose the pieces we can play. Never mind. So, all right, we're going to use Wireshark. Okay, so now, go to Start, All Programs, Wireshark. Well, if that helps you to do that. There's more than one way to do things. This is a network protocol analyzer. I think I've had to use it once before. So we're going to start a capture. Go to Capture, Start. Oh, sorry. Go to Capture Interfaces. And you want to start a capture on the Intel interface. Now, I have a lot more crap going on mine than you're going to have on yours. Yeah, because everyone in your machines has lost home, so they're freaking out. Because we unplugged them from the network and plugged them, so they're all going, ah, I can't find home, help. But you won't have as much traffic as I got going on. You'll have other stuff going on, right? So that's okay. So go ahead and minimize this. And then you can open up a command prompt. Okay, and you're going to type ping space, and now. If we roughly do this all at the same time, then you all get the same results. But if we don't hit enter all roughly at the same time, then what will end up happening is your MAC addresses will get recorded by everybody, right? But that's okay. So why don't we all, you two meet each other. So Terry and I can meet. On your microtrader, on the I'll come there and no, you guys don't ping each other. And you two are pinging each other, and you two ping each other. So trade IPs, I'll combine and get them set up. Did you get a light there? We could overlay that connection. Okay. So there's something wrong with yours. So we can't do the overlay connection. I don't think you're linked up. So what number were you? Okay, so go ahead. Why don't you just ping him, or I'll get him there. Go ahead and ping him. Well, you can do it. Doesn't matter. Go ahead and ping him. So no, you can just ping him too. He gets it. So all right, now
Once you've done successfully pinging, what's your letter and number over there?
832.
832. Yeah, I don't think you're linked up. I think you got to check your number.
832.
Yeah, you're in like 836 or something, so go change that. So, all right, now when you're done capturing, when you're done pinging, go to capture and click stop. Find it? 832. Where is it going? Really? Got a link? Let me look at what you got going on there. Okay, that cable, look, that orange cable has to be plugged into the back of the PC. The blue cable, you have to unplug the blue cable, put that orange cable back. What's that? That means that there's a disconnect in your hardware. That means the hardware is not connected. Or you change the wrong account. Change this one. Yeah. So I think you have hardware failure. Well, here's the IP. I don't know. I think you have no, you can see right here. So you're in B25 and 26. It's B27?
Yeah, that's what I plugged everything into.
Yeah, it's the second one. It shows that it's connected. It says B27 there?
Yeah, that's what this green one wire was.
Oh, you're the orange wire, not the blue wire. You get a message on your machine right now? Did your Windows come up with the messages now? It said like disconnected or connected?
Can you do it again? No. Okay, now it's connected.
We connected again?
Yeah, because it had a little triangle over that.
And now ping again so we don't. It's not working. So what I did is I messed up. I had to be on. Okay, what's this right here? Orange was something that was on the way. Blue one. There. Oh, let's check it. I'm going to check it. And the blue one was the one that was already there, right? No, oh, this, you can't use this cable. This is the bad cable. This is the cost. You can't use that cable. You got that. So use this cable. I'm going to do that. I'm going to take that. I got that as your IP. What the hell? What? It still don't work. General failure. I was verifying that that was the IP. See, general failure almost always is almost always a hardware failure. So check that cable out. Let's pull that blue cable. It could be a routine on there. Is it a blue cable or the orange cable?
The orange one is the one I connected to that my machine. I plugged the blue cable from my machine.
Oh, okay, okay, I see what you're saying. So you're saying that's B27.
Yeah.
And it's orange. Yeah. I don't think there would be a problem with that cable. Hardware failure is almost always because it's disconnected.
It's just coming up there on field. Yeah, yeah. Well, it's got to be one up in the field. It's got to be one up. One up there. Maybe that's usually that case, but maybe you see trying to pay, but you don't have that. Oh, you're trying to pay something out of the gator. 92 pounds. There you go. Awesome. No, it wasn't. It was two things. It was you were in a different network than him, and you didn't have a gateway. When you don't have a gateway, it's like, I know what to do. Okay, how are we going now? What became one? 32. You're number 8. And what's your link like that? Let's check 33. Do they go up? Sure. These are let's go ahead and see. Okay, I see a link like now. I see a link like now. The light must have not lit up or something. It's weird. That orange cable with the original cable is connected. Oh, it was? Mm-hmm. Now, where did you just plug that back in? You plugged it. Did you plug that back to what it was originally at? Yeah, you plugged it in the blue cable. So we want you into 32, right? 32 is the top. 32 is the top. Is it lit up? Is the light back on the machine? Yeah, it's on. Okay, you're good then. All right, why don't we clear out your, you got it? All right, so what you want to do is Wireshark yourself while you're pinging, and then stop the Wireshark. So let's do this again. Why don't we do this? We'll let's do capture interfaces, and let's start a capture all over again.
So we're going to do an info.
Yep. So everybody's ready to ping, right? Actually, you know what? Let's do it this way. You two right here. I'm only going to have one of you ping. So you are going to ping him. Don't do it yet. Wait till we're all capturing. We're all going to see it. Okay? So I'll time this. Okay. So no, don't erase that. Clear that out. Okay, now they really think. Okay, everybody started your capture, right? Start your capture, start your capture, start your capture. Okay, now ping. Everybody's ready? Everybody's started? Okay. Say, don't say. Don't say. Everybody's, you're capturing? You're capturing? All right, do the ping. Okay? Okay, stop. Everybody stop the capture. I only want one person ping. So everybody start get your command prompt up. I'm only going to have her ping. She's the only one that's going to ping. I want you all to see it, but I only want her to ping. All right? So let me wipe your cache up. Behind us. Okay. So get ready to ping. Okay, everybody restart your captures. So everybody restart your captures. Okay, everybody restarted yet?
How do you restart the capture?
Continue without saving. Okay, go to capture interfaces, start, continue without saving. Okay, now everybody started, go ahead and ping. All right, she just sent out 4 pings. Okay, go stop your captures. All right. Now what I want you to do is look for the first packet that went out from her. It was an ARC. It would have been an ARC request, and it would have been an ARC report.
192.168.1.13.
Yeah, I want you to find that.
I found it.
Okay, did everybody find it? Okay, now I want you to examine that packet. So find that frame and click on it. All right? And you don't have to double click on it. If you just click on it once, then in the middle part of the pane right here, in the middle part, that's the detail. You see that? See the middle part? That's the middle part. Okay. But I want you to find the first one she sent. She sent an ARC first. Right here. Cool. That's the first one. See that? So let me see if you can answer some questions. Okay? First off, why is it that we all saw that frame?
All in the same network.
We're all in the same shared network, right? There's another reason why we all saw that frame. Very good. It's a broadcast. You're awesome. Very good. Broadcast. So we saw it for 2 reasons. It was a broadcast, and the other reason is we're all in a shared same network. Now, how big was this frame?
It was 60 bytes.
Yep, it was 60 bytes. So in order for her to send an ARC, she had to consume 60 bytes of traffic. So, now I want you to branch out the Ethernet 2 header. Now, I'm going to open up a screen here for you, and this is going to really be confusing. So just get prepared. Get prepared for total confusion. What? I just got to tell you, man, it gets deep. This stuff gets real deep real fast, right? So, I got to go to images. What would I do without Google Images? I don't know. Okay. When the Ethernet first came out, it was called 802.3 because the IEEE created a project model called the 802 project model. And they came up with a whole bunch of 802 projects. 802.3 was called Ethernet. 802.11, which you're familiar with, is wireless. Right? So now you know where that comes from. Project. 802.2 was logical link control. And the purpose for 802.2 was to identify encapsulated data. It was the Christmas present, right? So Ethernet had no way to identify the encapsulated data. So instead it relied on 802.2. So we always stacked 802.3 on top of 802.2. So you had 802.3 your MAC address. Then you would add 802.2. The way they did that originally was you would have your Ethernet destination source and a length code, the attention length code. Then, and this was 1 byte, 2 bytes, 2 bytes, 2 bytes, and then you would have your data. Then they took out of this data, they created a destination SAP and a source SAP. These were destination things. Well, they only created 1 byte to do this. So they ran out of protocol room. They didn't have enough codes to represent all the protocols. So SAP ran out. So then they created SNAP. So SAP went to SNAP. And SNAP added all of this. The destination SAP and the source SAP is always AA.
so that it would be backwards compatible with SAP. Then they added a couple of fields in here. And these fields together would identify what type of data was in the data. What was in the data. So you have two ways of doing it. SNAP or SAP was the older one, then SNAP. Well, we had, 2 bytes, 3 bytes, 1 byte, 1 byte, 1 byte, then all these bytes. So you had, you could have 20 bytes or 16 to 20 bytes of extra data packed in just to send some small amount of data. So this is crazy. So some people came up with this, you know what, do we really need this length code? Maybe we could replace this length code and make this the type code and get rid of all this stuff. And that's what they did. Ethernet 2 is when you replace this length code with this type code. So how do you know you're looking at Ethernet 2 other than the fact that Wireshark is telling you that? So look at that Ethernet 2 frame. You tell me, how do you know that this is an Ethernet 2 frame beyond the fact that it tells you? See the type code there, right? That's it. So now,
What's trailer?
Trailer?
Yeah, it's trailer below the type AARP, and then below that is trailer and then 2 zeros.
Every frame has a header and a trailer. The beginning and the end. The engine and the caboose, right? Well, it's not showing you what is called the frame check sequence. Wireshark doesn't show you that. It just shows you all zeros. It's actually showing you the padding at the end. Now next. So I can type in Google Ethernet type codes. Here we go. What one do you have? What's your type code there? 0806. Guess what that is? Address Resolution Protocol. See that? So that's what's contained in it. So, how do you tell what's inside the layer 2 data with Ethernet 2? You look at the type code. And then you have a table of type codes. Right? And then right? So that's how we know the type code. All right, now what's next? What else is in the Ethernet header besides the type code?
Destination.
Destination MAC and source MAC, right? The destination MAC is 48 bits long. Now, I want to. What do you see in that field?
The destination.
Yeah, give you the whole code. The whole MAC. All right. Right? 6X. Right? Now this is special. This is all ones. This is actually 48 ones converted to binary. So if you convert these hex digits to binary, you would have 4 ones for each one of these. It would be a total of 48. 48 bits. So MAC address is 48 bits long. Now every MAC addresses have a special formatting. So I want to talk about that real quick. Okay. Pay attention to this diagram from Wikipedia. If you were to take every one of these and break them out, right? This would be 4. So this would represent these 4 bits. This would represent these 4 bits, right? And then this would represent then I don't have the rest of them, right? The first portion of this address, the first 6 hexadecimal digits, or the first 24 bits, is the OUI, or the Organizational Unique Identifier, OUI. The next place is the NIC. The next 24 bits, so this is the OUI, and this is the NIC. Right? The NIC is the network interface card. This 24 bits represents the actual NIC. So this is organizationally unique, and this is the NIC. Now, some of these bits have meaning. So the first 8 bits are where the meaning is at. Okay? So if you look at bits 8 through 1, this bit right here means something. If it's a 1, what is it? It's a multicast. If it's a 0, it's a unicast. Unicast means that it's directed right at a machine. Was this directed right at a machine? No, it was an ARC. It was directed for many machines, right? So this is marked as a 1. You will never see a 1 there on a MAC address for a machine. Okay? The next bit, which was what, bit 2, you will either see a 0 or a 1. 0 is globally unique, which means it's enforced by IEEE. So if this is a 0, that means IEEE enforces it. That means if you want to assign a MAC and you want to get an OUI, you have to go to IEEE and request an OUI so you can create MACs. If it's a 1, then it's local, meaning you've made it up, but it's only local. It's not organizational unique. You can only use it locally. Back in the old days, in fact, I have one. I'd have to dig it out. I don't know if it takes time. But back in the old days, we had Macs with bit switches on the back. You'd put the little bit switches because you would actually be able to program your own Mac. Then, as I grew up, they would give you a floppy that you could put into your PC and boot from the floppy, and then you could program the Mac from the floppy to the machine. But as we've gotten more mature, they're now burned in. They're called burned-in addresses. So this is already burned in. So Hewlett-Packard, Intel, Cisco, they all have an OUI, and then the IEEE lets them assign these out at will. So, for example, why don't you go down to, so we're on the ARC frame, go to the reply, click on the reply. You're on the ARC request, click on the ARC reply. The next one down, the second one down. Now, what is the destination MAC on that one? Read out the whole thing for me. Not the part that says Hewlett.
00, semicolon 1C, semicolon C4, semicolon 9D, semicolon 9C, semicolon.
Like that? Yes. So, now, Wireshark's smart. It automatically figured out that that was an OUI assigned to Hewlett-Packard. Did you see that? Now, if you take a look at this, though, I can go to Google and I can do an OUI lookup. Outlookup. Oh, what would that produce? I'm not quite sure. Not sure I want to know what that would produce. So here's my Wireshark OUI lookup tool. So I can type in that code you just gave me. 00 colon
1C,
1C
colon C4, colon 9D, colon 9C, colon 9C.
Hewlett-Packard. See that? So Hewlett-Packard is registered with IEEE. They've been given this OUI, right? And now they can randomly assign these next up. Any questions on that? So you now know the anatomy of the MAC. All you ever wanted to know how a MAC does. All right, so so now that you've got that, go back to the first one, the ARP request. Okay, so we've got the destination MAC, the source MAC, and you understand where I start from, right? And then you got your so you got Ethernet 2, and now go down to the, now, what I want you to do is click on the type code. Click on where it says type 0806, click on it. Look down below in the letters. You see the hex down there? That's the hex that comes across the network wire. So imagine it coming across the network wire and you're looking at the voltage yourself. You got the preamble, and then what's the first thing you see after the preamble? 1, 1, 1, 1, 1, 1, 1, 1, all F's, right? And then after all the F's, then what do you see?
0806.
No, look, you see all F's, and then you see 001C, C4, 9D, 9C, 9C, and what is that? That's the source MAC, right? So you got the destination MAC, which is all F's, then you got the source MAC, and then what is next? 0806, which is the type code. You follow? So are you seeing now what I want to make sure that you understand, and I think you're starting to get it, is you have now a stream of ones and zeros coming into your card, right? So the first 8 bits was the preamble. The next 48 bits was the destination MAC. The next 48 bits was the source MAC. The next 16 bits was the type code. Then what? Then ARP stuff, right? So now go down to the ARP stuff. Click on branch out address associated support. So this is your ARP request, right? And so it's basically asking, hey, I need your MAC. So who's going to respond to this, I need your MAC? The machine that owns that IP, right? And it should have responded with that machine's MAC. You see that's what happened? Look at the next packet down. You should see that that's what's happening. Okay, now, I've now taught you how to sniff a frame and examine the data link header and determine what's going on. Right? Now, you could see something like this. Let me show you this. You can just look at this up here. You don't have to actually do it. Maybe I'll find it. I downloaded it already so I can show it to you, but let me see if it's in here. I forgot what I called it. Hold on a minute. Oh, I don't have it here because it's on my, it's not the network account. Damn it. Let me just start a capture. Maybe it'll have a. Maybe I'll find one. Give me a minute. I might find one. I might find what I'm looking for. Just give me 1 minute. No, of course not. I'm not going to get lucky. Okay, I'm not going to find it. So give me 1 second. Let me go get it.
Okay, just a second, I'll find it. It's in this list somewhere. Here, I'll try this one. This one looks promising. Obsolete captures. I don't want a Linux cooked capture. Wouldn't help me much. Well, that one's not going to work. That's why it's obsolete. What I was going to do is here. Oh, here it is. I found it. I found the one I'm looking for. Sorry, it took me a long time. Okay, here we go. All right, so take a look up here. What is different between this one and what you're seeing? What is different?
All the traffic, the volume.
No, I'm looking at a specific frame or something. What's the first key difference you notice between that art frame you're looking at and here? It's bigger. 4 bytes bigger. What else? It's using a different what? First off, it's using a different data protocol. Notice that yours was using Ethernet too. This one is using what? Token ring, right? But what I want you to notice is that it's got a destination and a source MAC just like you do, right? But it doesn't have, there's other requirements, right? But it's got a destination, and it's got this access control feature. Notice it's got an access control feature in its header, which is different than Ethernet. Because Ethernet does different things than Token Ring does, right? Now, Token Ring does not, notice that Token Ring, what is it missing that Ethernet 2 has? Ethernet 2 has a destination MAC and a source MAC and something else. What is that? Type code. Does Token Ring have a type code? No, so what does it need? Logical link control. Guess what's next? Logical link control. Right? Now look at this. Destination SAP, source SAP. Because it's set to AAA, what is this type of logical link control? It is a snap. Snap is the newer version of logical link control. So this is snap. And so guess what? It has a type code. It's 0800. 0800 is IP. And there we go. There's your IP protocol. Make sense? By the way, here's an art broadcast. Here's the same thing you got, right? This is the same thing you got, right? You got an ARC resolution request just like this one does. Same format, right? The only difference is this one requires token ring and logical link control in order to get that packet out onto that network. Whereas in your Ethernet 2, all it took was an Ethernet 2 header out there, right? And the Ethernet 2 header's got the type code built into it. And it does not require all this extra stuff like access control. Like if you look at your Ethernet 2 header and we look at our token ring header, you can almost see, well, you can't really almost see, never mind.
I was going to see if we can compare. Well, actually, how big is your total frame and how big is this frame? How big was your frame, your ARC broadcast? 60 bytes? This one was 52 bytes. So this one was actually smaller. That's perplexing. I guess I'm sure why. Anyway. All right, any questions about this? Pretty easy to see, right? Not too difficult. Now go look at your ICMP echo request. So look at your ICMP echo request. The echo request should have a destination and source map, right? Okay, so go to your, open up your command prompt on your machine and type ARP-G. Do you see anything in there? Or does it say no ARP entries found? Now like this. ARP-G with spaces. Do you see anything in there? What do you see? Yeah, so you see the IP and the map, right? Now, do this. Do ARC-D asterisk. Sure, try it. ARC-D asterisk. And then type ARC-G. What's that? Now it says no ARP entries found. So your local computer has what we call an ARP cache. Right now your ARP cache is now empty. Go ahead and ping somebody, and then run ARC-G again and tell me what you see then. Ping somebody and then do ARC-G. Tell me what you see. What'd you see? You do ARC-G again, you'll probably pick up all the errors too. Because your machine, if it sees an ARC request, it also picks up those MACs too. So if you've got the MAC address in your ARC cache, guess what you're not going to do? Send an ARC out asking for the MAC. Okay. So now go down to find your IP echo request and find the Internet Protocol. Your header checksum is different? Really? Well, that switch is, that hub is really old. It could be dropping frames. That wouldn't doubt it if it was. So look at the IP. Notice you have the destination and source IP addresses, right? Do you see that? You can tell that it's got a protocol type in there. And then you can see your ICMP protocol message, which is your application layer message. All right, well, you've successfully been able to connect your machine up to a hub, and you've also now been able to snip the packets and then analyze them. Now, if I were to change this and connect all of you to a switch instead of the hub, how would this behavior, how would our behavior be different? Do you have any idea, do you have any concept of that? What would change? So, what's that? No. See, we're all on the hub. So when she pinged him, you could all see that traffic.
Oh, we wouldn't see the traffic anymore.
You're right. You would only see her broadcast. You would see her broadcast out, but you wouldn't see his reply. Why wouldn't you see his reply?
Because it's going directly on that machine.
Because he's sending a unicast frame. And the switch is smart enough not to forward it out all the ports, just the port it needs to be on. Right? So you wouldn't see all that. You would just see, right? You would just see her ARP request. You wouldn't see the reply. And you wouldn't see the ICMP going back and forth between them. Right? If I plugged you onto it. So this is why I had to use a hub for this exercise. If I used a switch, then I'd have to set up a monitoring port and plug you into the monitoring port so you could see all the data coming through the switch through a monitoring port. No, the hub is dumb. The hub does not have a MAC table in it. The switch has a bridging MAC table. So it stores what MAC is on what port. We'll get more into switch mechanics next class. It's part of the exercise we're going to do in here. All right, any thoughts about what we did tonight? Any questions? Okay, you have to clean this network up. So let me explain what has to go down here. First, you need to set this machine back to using a DHCP address, right? Second, make sure you listen to all the instructions. Second, you've got to reconnect yourself back up to the correct network with the blue cable. And then you need to make sure it gets an IP address and gets on the internet. And then you're going to log off and then log back on as your student account and make sure it works.
So we do the IP thing first or we connect it first?
Do the IP thing first. The logging off and logging back on as your student account to make sure you can get on the internet as your student account is vitally important. Oh, and wrap up the cables nicely and put them back in that little box.